Could you please verify, please? Yeah, Ishola, what's up? How are you? I hope you guys are doing great. So I'm just gonna apologize to you guys in advance because there's actually a lot that I have to do tonight. I'm actually paying a visit to see a sick friend in the hospital. So today's session is gonna be just 30 minutes. What's up, Ishola? I hope you're doing great. So let's utilize our 30 minutes, please. Let's utilize our 30 minutes. So what's up, guys? Welcome to another exciting edition of our session. Today, it's going to be another machine learning session. I think today brings us to almost the end of our machine learning part of the course because our next session is going to be building dashboard, and then we'll start talking about our capstone project. Yeah. Okay, good evening, Sharon, what's up? Sharon Joseph, what's up? How are you? I hope you're doing great. So let me just go ahead and begin. Today, we're going to be covering some unsupervised machine learning concept, where we're going to be doing some clustering. Yeah, so just shift this whiteboard to the side before we begin. And before I proceed further, I always like to start my notebook. I see a lot of people are still having issues starting up their Jupyter notebook. By this time of the, what do you call it, hackathon or data analysis session, you guys are already intermediate data analysts. So by now, I'm surprised some of you guys are still having issues starting their Jupyter notebook, which is weird, honestly speaking, which is weird, right? Because I've recorded an entire session for you guys whereby I installed Python to my machine, and I also installed Jupyter Notebook, right? So it's actually very easy. Just go to your file where your notebooks are located. Just go to this address bar, which is here, and then type cmd, which is just going to open a command prompt in the current working directory. And what you have to do is just to type Jupyter space notebook, and this is going to open the Jupyter server on this local host, right? And it's just automatically going to open your browser. As simple as that. I see no reason why you guys are still having issues with opening your Jupyter notebook. As you can see, it's going to open this page for you, and then after that, you can just go ahead and click on new to create your new notebook. And then if you want to open your existing notebooks, then you can as well go ahead and open your existing notebooks. So without any further delay, let me just go ahead and create a new notebook while we explain the concepts in the whiteboard. So I've already clicked on new notebook once, which is automatically going to create a new notebook and redirect me to that page. Yeah. So please, in the chat section, go ahead and say how many of you have done the iris. I believe last 2 weeks or last 2 weeks, I gave you guys a challenge to go ahead and analyze the iris data set. So please, how many of you have done that? How many of you have done that? So while the notebook is loading, I'm just going to go ahead to my notebook, sorry, to my whiteboard, and explain some few concepts to you. Let me just get my stylus ready, and then we move on. Nice one. Yeah. Let me see if my whiteboard is. Yeah, nice one. So today we're going to be talking about an unsupervised machine learning concept, because we have already talked about supervised, right? Supervised, where we covered some linear and logistic regression, right? Linear stroke logistic, right? So today we're going to be talking about, we're going to be doing some unsupervised learning. Unsupervised, right? Unsupervised. So let me just check the chat section for a while. Okay, nobody has answered. Please, if you've done the iris data set, please go ahead and drop it in the chat section. So So today we're going to be talking about clustering algorithms. Clustering. Today we're going to be talking about clustering. And so clustering is let me just change the pen to red. I believe maybe that by that is going to give us some, well, let me just change it to blue. Yeah. So clustering is actually very simple. Clustering is an unsupervised. When we say unsupervised, what do we mean? Unsupervised. Please let me see that. Even though we have limited time, let me just, I want to give you guys quality stuff. I don't want to just rush because of my personal stuff. I want to give you guys quality content. So please go ahead and tell me, what is an unsupervised? What do we mean when we say unsupervised? Okay. Okruma Joseph, personally facing the challenge, but the issue is not that I cannot do it, but it seems either my system, I have an error of the libraries because I have been doing it several times and all the classes, participant, I have done all the class practicals, but now as it has started giving me issues and I cannot get access to the save files. All right, if you cannot get access to the, see, Jupyter Notebooks automatically save files, automatically save your files. I see no reason why you're going to have, is it okay, Joseph? I see no reason why you're going to have issues with your Jupyter Notebook, right? It's actually automatically saved, right? So that's why I asked you guys to create a GitHub account, right? Had it been you saved your Jupyter Notebook in your GitHub account, it's going to be here 10 years from now. It's going to be there. Nothing is going to happen to it because it's on the cloud, right? So please go ahead and answer in the chat section, what is an unsupervised learning? I want you guys to familiarize yourself with the concept before I even begin. What is an unsupervised learning? Today, we're going to be talking about unsupervised because we have done supervised. So what do we mean by unsupervised, please? Unsupervised. When we say unsupervised, what do we mean? Okay, let me just give you guys an expo. For supervised, we give the algorithm a data and a label, right? For example, we show it like an orange or an apple, and we give a label. We tell the algorithm that, hey, this is an apple, right? So when we say unsupervised, what do we mean, please? Unsupervised. Unsupervised. Have you guys forgotten? Have you guys not been practicing? Yeah, nice one. The ladies are answering. George, okay, I don't know if it's a lady because the DP shows a lady. George Oluwaseun. Okay, George, it says unsupervised is given the model. The model is allowed to examine the data in order to identify. Yeah, you're absolutely right. The model is allowed to identify some patterns in the data, and then it identifies, right? Unsupervised is given the algorithm data without label. Yeah, Joseph, you're right. So yeah, I'm okay with that. I can please go ahead and mute your mic, please. Go ahead and mute your mic. So clustering, please pay attention here. Mute your mic, you are distracting the class. Please mute your mic. Please mute your mic.
The host should mute all now.
Mute your mic, please. You are distracting the class. So when we talk about clustering actually learns from data itself rather than the labels. What? Learns from data. These are the key points that I want you guys to understand. Learns from the data itself, right? Learns from the data itself rather than the labels. For example, you just give it an apple and then it recognizes all the patterns, all the edges, the shapes and everything, all the curvy shapes and everything. And then it identifies this as an apple, right? It learns from the data itself rather than from the labels. As simple as that, right? In supervised learning, you have to give the data and then you have to give the label, right? As simple as that. There's no big deal about it. So clustering does the same thing because it's an unsupervised learning, right? Learns from the data itself rather than what? Rather than the labels. So it splits the data into distinct groups. It splits the data into distinct groups based on the feature provided, right? Based on the feature provided. Let's say, for example, let's say we have the iris like this. let me just go ahead and draw something weird that resembles a flower. We have the sepals and petals like this. So based on these features, based on these petals and sepals, right, it splits the data based on these features. For example, we have the length of the flower, we have the length, and we have the width, right? These are just sizes. These are sizes. For example, this could be something like 3.5 centimeters, and then the width should be something like let's say, which one is longer? Let's say 4 centimeters, right? And the sepal, let's say the length is going to be something like let's say 2.6 centimeters, and then the width is going to be something like let's say 1.2 centimeters. So based on this, based on the size of the flower, it can be able to identify this as what? It can be able to classify these as one of the classes of the iris data set, right? It learns from the data itself rather than just showing this iris without any dimensions of the flower and then just saying this is iris setosa or something like that, right? Right? Very good. So there are some types of supervised machine learning algorithms for classification. We have the DB scan. We have the DB scan, and then we also have the Gaussian mixture modeling, right? Which is a bit advanced. Gaussian mixture modeling. So I want you guys to pay attention. And then we have K-means cluster, K-means, right? We have K-means. We have K-means, which is what we're going to be focusing in our today's session. K-means, right? This is one of the most simplest and one of the most effective techniques in clustering algorithms, right? So we have DB scan, we have Gaussian mixture modeling as well, and then we have K-means. K-means is one of the simplest and one of the most effective classification algorithms out there. So we're going to be covering this as well, right? So, so the main objective, how does it work? Let me just move this aside. So now you guys know that clustering is part of unsupervised learning. It learns from the data itself rather than what? Rather than the labels. For example, even though you can solve this iris flower issue with a supervised learning, you can be able to solve this with an unsupervised learning as well. So, right, we have some few types of clustering. We have the DB scan clustering, we have the Gaussian mixture modeling, and then we have K-means cluster. If I were you, I'll be taking notes, right? Though you have the video, anytime you can go ahead and take your notes. But actually, learning is effective when you take notes in real time, right? So how does it work? Let me just change my pen to red color. How does it work? See, the key is knowing how these algorithms work, because the coding part is actually very simple. If you know how it works, the coding part is actually it's not a big deal. So how does it work? How does it work? How does it work? We don't just throw in algorithm. We split the algorithm and see what's hidden under the hood. So the main objective, right, of the K-means clustering algorithm, right? Don't mind my handwriting, please. I don't write more often, I only code. So the main objective of the K-means clustering algorithm is to reduce the sum of the distances, right, between the clusters. Don't worry, I'm just going to go ahead and draw something so that let me just go ahead and draw. Let me draw my chart so that things are going to be easy for you to comprehend. Right? So let's say you have your X and Y axis like this, just like we always do. Let me just take you guys, let me go time a bit. As you can see, this is what we've been doing so far. We always draw our X and Y axis and explain things. So we're going to do the same thing for the clustering algorithm. Let's say you have your X and Y axis, right? And let's say, for example, you have some data points, right? let's say you have some data points here. Let's say you have some data points here. For example, 1, 2, 3. Let me just add 1, 4. And let's say you have another one. Let me just change my pen color to. So let me just leave it as white. Let's say you have another data point here, right? Let's say you have some few data points here. Let's add another one. All right, let's add 2 more. Okay, then let's say you also have another data points here, right? Let me just make it 3. So by me looking at these data points, you can see that this is another class. This is also another class. This is also another class. It is clustered into 3, right? It is already clustered into 3. So if you have a data that is clustered like this, you know that you are having a clustering problem. You're going to be solving a clustering problem, as simple as that, right? Whenever you have a data points like this, you automatically know that you're solving a clustering problem, right? So the first thing that you have to do is to define the optimal way to get the K number. This is what we call a K number, which is the alphabet in K means plus, right? K. The optimal way to get the K point. When we say the K point, what we mean is, for example, you're going to, by default, the first thing that the algorithm does, it places random K values, random K points, right? Random K points on the cluster to split the data. For example, we can see that this data has 3 clusters. So the algorithm might randomly place, let's say, for example, place a point here. Let me just change my pen color. Let's say it randomly place a point here. And then, don't worry, you're going to understand in a bit. Maybe randomly place another point here. Right? Let me just paint this so that you can easily differentiate it with the rest. Then it could randomly maybe place, let me just change this to a point here, right? So we have 3 clusters, right? And then we randomly place 3 points in the clusters. So, but it's a matter of trial and failure. A lot of beginners ask me, how do we determine the number of points on our clusters? It's actually a trial and error. For example, by me looking at this cluster, we know that we have 3 clusters. So K could be 3 because 3 points, 3 clusters, we successfully added 3 clusters. So K is equals to 3. 3 clusters is the optimal way of placing these points, right? So the next thing the algorithm does is it selects the point within the data, right, which will serve as a starting point. For example, let's say you want to group this. Clustering is just grouping things into their own groups, right? So for example, what the algorithm is going to do is to select random points within the data that will serve as a starting point, right? And then what it does next, it calculates this, what we call an Euclidean distance, which is just a distance between points. Euclidean distance. Please pay attention to these concepts. Distance between what? Between 2 points. That's Euclidean distance. So it's going to measure the distance. For example, let me just check, somebody is dropping a comment. All right, engineer network is very poor. Don't worry, the video is clear. You can go ahead and watch the video again. So the next thing it does is it calculates the Euclidean distance between the centroids, right? Between the centroids. For example, by me looking at this, you know that these points belong to this. The closest distance from this to this, right? So we automatically know that this one belongs to this blue group. And by me looking at this, we know that this one, let me just change it to red. We know that this point is closer to this, right? So the algorithm is automatically going to classify this one as the red team. And then by me looking at this, we know that what? We know that this point is closer to this, right? They are almost close. So it's going to cluster this. as part of white, right? So what does it do next? The next, after connecting to the nearest neighbors, what it does, it calculates the Euclidean distance between them. As simple as that. It calculates the Euclidean distance between the point and the nearest data, right? It calculates the mean. For example, it's going to repeat the same thing. It's going to calculate the mean, the average between this point to this point, right? The average distance between these 2 points. That's what it does, right? So, for example, after calculating the average, it's going to adjust this. If this data is far away from this point, it will shift. Let me just use my duster to clean. It will shift the point closer. It will shift it closer like this, right? We know that. Okay, let's do the same thing for this. It will calculate the average distance between these 2 points. It is a bit far, so it is going to shift the centroid, the center of the data, to somewhere around here, right? From here to here. So let me just go ahead and clean this. Just go ahead and clean this. And by me looking at this, you guys have already guessed it. It calculates the average distance between these 2 points. It is going to shift the center of axis to this middle, right? So let me just go ahead and clean this as well. Right? Just clean this as well. So now we know that after shifting, we know that this is closer. So this also will belong to the what? Will belong to the white group. This will belong to the white cluster. This will also belong to the white cluster as well. So it is going to calculate the distance again, right? The average, it will continue the step again, calculate the distance between them. Okay, this is far away. It will reduce. After calculating the average, please mute your mic, please. It will bring the case center to this place, right? So let me just go ahead and clean this. Let me just clean this. And then it will do the same thing for this. It will calculate the average distance, and we know average now, we just divide, right? So it's going to bring this even to the middle again, and it will calculate it from the other points. So it will automatically cluster this to the blue group, right? And then it will shift. It will continue calculating for the white group. It is almost in the center. So there's no calculation for the white again. So, but for the red, the center is a bit far away. So it will split and calculate the average distance, which is going to shift its red center to almost somewhere around here. So this will automatically turn this group to red. As simple as that. That's how the algorithm is working. It will just place random k points on your data, right? Random k points. And then it will calculate the average distance between the points that it created from your data point. It will calculate the average, shift the point, calculate the average, shift the point, calculate the average, shift the point, until there's no average to calculate. It will just calculate the average and it will be the same. Then the algorithm will stop calculating. Then it will cluster all the neighbors to that group. That's why we call it a nearest neighbor, cluster nearest neighbors. If you understand the concept of neighbors in real life, so that's basically what's happening, right? That's basically what is happening. This is my neighbor, this is my neighbor, this is my neighbor. So it groups them into together. Birds of the same feather, right? Birds of the same feather. It's actually very simple. Place random points, calculate the average distance between the points and your data set, keep reducing the distance until that point is in the middle of the cluster, and then cluster all as part of that army. As simple as that. I hope you understand. I hope there's no any complication around it. Please, if there's any complication in this explanation, please go ahead and drop it in the comment section.
Hello.
Is there any complication, please? This actually, honestly, is very simple.
Yes.
Is there any question?
Yes.
Okay, what's the question? Please go ahead and ask, because I'm just going to the programming part of this thing. What is your question, please? What is your question? We don't have enough time. Please go ahead and ask your question.
I don't understand very well all the solutions.
What? You have to, what is it that you don't understand? You have to be specific.
What you just explain now?
You don't understand?
Yes.
You mean you don't understand everything?
Yes.
Okay, let me use layman's method to explain to you. Are you listening?
Yes, sir.
Let's say you have your x-axis. Shebi, you know x and y.
Yes.
Okay, let's say you have random clusters here. Let's say you have white team, right? Is this white team? Okay, and then let's say you have red team, like the red team. Do you understand?
Yes, sir.
And then let's say you have blue group. Let's say you have blue group as well on your data points, right? Right?
Yes.
So the way clustering algorithm works, it's, for example, the reason why we're doing this, let's say, for example, you have a new person. Let's say a new person comes to your neighborhood. Let's consider this as a neighborhood. Let's say this is a neighborhood, right? So if a new person comes into that neighborhood, we want to assign that person into a group, right?
Yes.
So let's make this yellow, something like yellow. Let's say a random person came to that neighborhood and then we want to group that person, right? So what the algorithm does for training is it will assign random points. For example, it will assign a random point here. It will also assign a random point here. It will also assign a random point here, right? And then it will calculate the distance between the point and the people of the nearest group. And then it will take the average and then remove the average from the distance and then shift the point until this point is in the middle. It will do the same for this. It will bring the point to the middle. Calculate the distance between the point and the group members, and then it will shift the point to the middle. After that, these three random points, they are known as centroids. They are called centroids. Do you understand? Are you understanding?
Yes, sir.
Very good. So now we have a white center. We have a red center here. We have a red center here. And we have a what? We have a blue center here. This is the center of each neighborhood. So by me looking at this yellow person that came in, right, we know that we could do something like this. Okay, we are going to calculate the distance from that yellow guy to the center of our neighborhood, to the center of our clique. Calculate this thing from the yellow to the center of the red team, from the yellow center of the white team. So based on this distance, where do you think this yellow will be? Which group do you think this yellow will fall into? Based on the distance, which one? The yellow is closer to which team? Is it closer to white or closer to blue or closer to red?
Blue.
It's closer to what?
Blue. Blue.
It's closer to blue, right? So it is going to label this new data. It is going to automatically, so we consider this blue as prediction. That's the prediction, as simple as that. That's the prediction, right? Whenever you bring a random data point, for example, let's say another one comes and the data points happens to be here. Let me make another example. If this data point happen to be here, where do you think this person will belong to based on the distance from the center of each group? Where do you think this one will belong to? Is it red or white?
White.
Very good. That's the prediction. That will be the prediction. So the main aim of this algorithm is to find an optimal way of the center of each cluster. So if it finds the center of each cluster, whenever you bring a new data point, whenever you want to make predictions, it will refer that data point to the center of each cluster. Based on the Euclidean distance, it will predict that new data point as part of each and every group. Do you understand? Do you understand? Let's say you have a group of 3 tribes and you have your center. So if somebody comes, if a new person comes and if that person is near to tribe A, you know that you can automatically predict that he will end up joining tribe A. Why? Because he's closer to their center. Abi, if that new person is to the red, we know that it's going to belong to the red cluster, and if it's near to the blue, we know that it's going to belong to the blue cluster. So, yeah, that is how the clustering algorithm make predictions. After finding the optimal way to place points in the middle of your data, then it will save that distances. Whenever you have a new data, let's say for example, this is a yellow mango. This is a yellow mango, right? Let's say this is a green mango, right? And then let's say this is a red mango, right? And it has already made all these predictions. Let's say you have a new mango and you want to predict what type of mango is it, right? If the features of the mango is closer to red, it is going to predict that mango as red. If the feature of the mango is closer to yellow, it's going to classify the mango and predict it as yellow. Same thing goes for the yellow mango, as simple as that. So if you understand this, you're going to be okay with clustering algorithms. It just groups your data into clusters, as simple as that. So please, if you understand, we can just go ahead and move to the coding part of this, which is very, very simple. The most difficult part is understanding how the algorithm works. So a lot of people ask me, when do we even use this? When do you know that I have a clustering problem that I have to address, or this is a clustering problem? How do you even know that you are having a clustering problem, right? How? For example, whenever you want to detect anomaly detection, when you want to detect something that does not belong to a group, anomaly detection, right? Whenever you want to group your customers, let's say you want to group your customers, right? Based on, let's say, high-paying customers, this customer, I know, by me looking at that, this one is not even buying things from me. This one is not even a well-paying customer. You've already, in your brain, if you're someone that is in the business or marketing something, you already know some of your customers. You know that this one will just buy something for maybe 10,000 naira and go. This one is a very good customer. It's going to maybe shop for almost 1 million, right? In your brain, you are already clustering your customers. So let's say you're having millions of customers. It is going to be beyond the capacity of your brain to cluster all your customers, right? So you know that you're having a clustering problem. Now you can create a clustering algorithm that is going to segment your customers. High-paying customers, right? Low-paying customers. You categorize your customers, right? One is a very good customer. It's going to maybe a shop for almost 1 million, right? In your brain, you are already clustering. So let's say you're having millions of customers. It is going to be beyond the capacity of your brain to cluster all your customers, right? So you know that you're having a clustering problem. Now you can create a clustering algorithm that is going to segment your customers. High-paying customers, right? Low-paying customers. You categorize your customers. Please go ahead and mute your mic. Please go ahead and mute your mic. It's echoing back. You are already clustering. Please mute your mic so that please go ahead and mute your mic so that we can just go ahead and begin our class for today. So for example, today we're going to be covering this iris data. We're going to be classifying, since we're talking about we're going to cluster this iris data set into 3 clusters. The reason why we're choosing this data set, number one, is because it's readily available in the Seaborn library, and secondly, it's actually one of the amazing projects for a clustering problem, right? So I'm just going to go ahead and let me see if I can find a way to add this image into my workbook. Should I download it or should I programmatically add it? Let me see, which one should I add? Let me see. Should we download the image or should we be like programmers and then add it programmatically? Let me see. Okay, let me just choose this one. I'm just going to right click and open this link in a new tab. Why am I having this issue? Wow. I don't know, whenever I'm having a Zoom meeting, my network assumes that I'm on a bad server or something like that, security vulnerability or something like that. I don't know why this mostly happens to me. Let me just go ahead and search Iris dataset, Iris flower levels HD. So we're having network issues. I don't know why. I have to restart my router, but honestly speaking, this is going to waste our time because we even have limited time. We have already exhausted the 1 hour itself. I was even thinking of staying here for let's say something like 30 minutes or something like that, but I've already wasted more than almost an hour here. So let me just go ahead and I don't know how I can get the, let me check my phone if I can be able to get the link to an image, then I can be able to hard code the URL into this. Let me just give me a moment so that I can try these things, please. Let me see if I can get a link. Let me see if I can get a link. Yeah, it's opening on my phone. So let me see if I can be able to, if the URL is short, then I can just go ahead and type it here. And if it's not short, then we can just move on without this thing. Wow, the URL is so long. Iris image, iris flower image. Just give me a minute. I'm trying to download the image so that you can see what we are working with. I got the image, but the link is so long to type, honestly. Let me find the one with the very short link, then we can go ahead and type it so that we can get it programmatically into our computer. Honestly, yeah, the links is so long. I don't know, maybe, okay, let me find a way to add that link to my GitHub. Then maybe from there, I can copy the link. Let me see if I can be able to do that as quickly as possible. Yeah, let me just go ahead and add that to my GitHub as quickly as possible.
No problem. Of course.
Okay, let me see if my email opens, then I can just drop the image link to my mail, and then from there we can copy the image link down to the notebook as well. Wow. Seems like this thing is giving us, this thing don't want us to, I don't know. My router doesn't want me to use this image. Let me just copy the link and try. If it doesn't work, then we can just move on with our life because honestly, we don't have enough time. So let me just try and add this to my, wow. Wow, that's amazing. Honestly, I'm super impressed with that. So we are able to programmatically add the iris image into our notebook. That's beautiful. That's the power of problem solving skills. So yeah, beautiful. So we have the iris data set here. If you pay close attention, we have the what? We have the iris setosa, we have the iris versicolor, and then we have the iris virginica. If you take a look at this, if you take a look at these flowers, they're literally by me looking at them, they look like they're the same, but honestly speaking, they are not the same, right? So how do you group this into, how do you cluster them, right? If you can apply clustering to this, you can be able to apply clustering to any problem, right? So how do you actually apply clustering to this? For example, if you take a look at this sepal, and for the iris setosa, and if you look at the sepal for the iris versicolor, the one for the setosa is bigger than the what? Than the one for the versicolor. And if you take a look at the iris virginica, the sepal for the iris virginica, the iris versicolor sepal is bigger, right? And the petals is for this is bigger than this, and for this is bigger than this as well. So that is how the algorithm is able to is going to be able to classify them into, cluster them into three clusters. So without any further delay, let me just off my mail. I'm coming. Let me drop the link with the labels to my mail as well, so that maybe let's see, maybe we can use it as well. The one with the petal length and width. Let me see if I can drop it to my email as well. So let me just try something. Control 2. Yeah. So I already have my tool, so I don't have to drop it. So as you can see, we have the length. Let me just do Control 2. You can see the size, right? The size, the length and the breadth size of the sepal and the petal, right? As simple as that. The length, right? And the width of the sepal and the what? And the petal. And then we have them as values, right? This is the length of the petal, the length and the width of the what? Of the sepal as well. So by me looking at this, we know that we can be able to cluster them into 3 clusters. So without any further delay, let me just go ahead and import the data. The first thing that we always do is to import our libraries, right? Let me just go ahead and import libraries. Import the libraries for clustering, right? So the libraries that we're going to be needing, we're going to be importing pandas. Import panda as what? As PD. I'm going to be importing NumPy as what? Let me zoom a little bit. I'm going to be importing NumPy as NP. Honestly, there's not enough time. I'm going to be importing matplotlib.pyplot as PLT for the visualization, and I'm going to import Seaborn as what? As SNS, and then I'll be importing, the next thing, let me just import the iris dataset. So the iris dataset is actually located inside scikit-learn. We don't have to download it. So from scikit-learn.datasets, right, we're going to import, just like we did in our previous class, right? Load, I think it's load hyphen, or is it underscore or hyphen? Let me just try hyphen. If it doesn't work, I'm going to try underscore load iris. And then let's import our model from, let's import the clustering machine learning model. So from scikit-learn, let me just import the trend test split from scikit-learn.model underscore selection. What are we importing? We're importing the trend underscore test underscore split. Please go ahead in the comment section and explain to me what is the actual function of this trend test split. We've been doing this for almost a month now. What is the actual function of trend test split? Please go ahead and answer before I finish. The next thing I'm going to be importing is the k-nearest neighbor classifier. So from sklearn.neighbors, import what? The k neighbors. Am I typing it correctly? K neighbors classifier. Yeah. And then from sklearn, .metrics. I'm not going to import the rest. I'll be importing them maybe later on, right? Import NumPy as NP, not NumPy, please. As import NumPy. Okay, we're having two as. Import NumPy as NP, and then the load iris is actually underscore, not hyphen. Load iris. Beautiful. So now we have already imported our libraries for the machine learning algorithm. So let me just go ahead and check the trend test split to split our model into training and testing. Very good. Very good. To split our model into training and testing. So the next thing I'm going to do is I'm going to be importing the libraries for validating our model, right? For validating the model's accuracy after prediction. Validating our model, right? Nice one. So and then the libraries that we're going to be using, why am I having errors? Seaborn, okay, there's N. Import Seaborn, there's N as SNS, Seaborn. Nice one. So the libraries that I'm going to be using for the validation of our machine learning model is we're going to be importing confusion metrics, just like we have done in our previous classes. And then we're going to be importing classification report to see the accuracy of our model. And then we're going to be importing standard scaler so that we scale our data, right? The reason why we're scaling our data is we want our data to be in close range. We don't want some of our data points to be bigger than the other one. So if you scale them down, if you transform them, they are going to be within the same range. So I'm having another error, no module name cycleland.model selection. Okay, I typed it as double E, it should be single E. Yeah, model selection. Yeah, no module name, sklan.model underscore selection. From sklan.model underscore selection. Yeah, it should be correct, right? From sklan dot no module name sklan.model underscore. Okay, there's no E on the selection. Model selection, E. Beautiful. So the next thing that I'm going to be importing is I'll be importing my classification report. Wow, we're having, actually I'm rushing today. So neighbors classifier. Wow, the spelling is wrong. So let's type neighbors slowly, please. K nearest, K neighbors, EIGHBORS, then classifier, CLASSIFIER. I believe that's the correct spelling. So the next thing that I'm going to be importing is the confusion matrix. So from sklan dot metrics, I'm going to be importing the confusion matrix. Confusion underscore matrix, and then classification report. Classification underscore report. This is going to give a summary report on the performance of your model. Is it accurate? Is it not accurate? How many of the predictions are correct? How many of the predictions are wrong? So that's basically the classification report and the confusion matrix. So I'm going to be importing another function for placing the random K points in the middle of the neighborhood, which is k-means, right? So from sklan dot cluster, right, I'm going to be importing k-means. This will be responsible for placing the random points in the middle of your data points. So k-means, right? And then the next thing that I'm going to be importing is the standard scalar to scale our data. So from sklan dot what dot pre-processing. Pre-processing, I'm going to be importing the standard scalar just like we did in our previous class, please. The standard scalar, right? And then let me just import principal component analysis so that I'll just show you guys as quickly as possible. I'm just going to write it down, and then maybe in our next class we'll be explaining things more. From sklan.decomposition, I'm going to be importing my principal component analysis, PCA, decomposition, right? And then I'm going to be importing PCA. Yeah, invalid syntax, all right, on line 3, okay, from sklan, okay, I type double O. Hopefully we are not going to be having, okay, confusion matrix on line 3 from sklan dot pre-processing import standard scalar. Okay, there's an error there. Pre-processing, let me check. From sklan dot pre-processing import what? The standard scalar. Okay, the scalar is actually single L, not double L. So let's see. If we don't have any error, then we can move on with our lives. So the next thing I'm just gonna do, I'm just gonna load my data set as quickly as possible. There's not enough time. I'm just gonna load my data set. Load data set. I'm just gonna go ahead and load my data set. Let me change this to Markdown. No, this is not actually a valid Markdown. Nice one. So I'm just going to be loading my data set, which is the iris flower data set. So iris is equals to what? Load iris, which we imported here. We already imported load iris. We've already done some of these things. So during our logistic regression, right? We've already done this thing, right? So I've already loaded my data set. So how do I see the data set? Let me just say iris. You see, this is a data set, but let's convert it to a data frame, right? It doesn't make sense like this. It doesn't even have columns. So let's add some columns to that. We can use pandas to do that. So we can create a variable called df and then pd.dataframe. Let's create a data frame from that. pd.dataframe. The data frame that I want to pass is the iris data, iris.data, right? As you can see, the first column, sorry, the first item in the dictionary of the iris is the data, then the rows, right? So iris.data, right? So in the iris.data, I want you to add what? I want you to add columns to it. Columns is equals to what? Iris.what? Feature names. The feature names of the flowers. The feature names, right? As simple as that. So let me just say df and c. All right. We are having errors. The name df is not defined. Why? Why is it not defined? I just said df. df is equals to pd.dataframe, iris data, and then, yeah, let me just run that again. Maybe it's, wow. Why are we having these issues? Okay, let me load the iris, and then let me load my df as well. df is not defined. Sorry, not df, pd.dataframe. I'm using pandas, pd.dataframe. Sorry for that. Yeah, now if you see, now you see that it's beautified. Now we have column names, right? So what am I doing here? It's actually very simple. When we loaded the iris, it's not giving us some column names, right? So that's why we use pandas to add these column names. These are the feature names that are in the data set. So we converted the feature names to columns by simply saying columns is equals to the iris data dot feature names. The feature names inside the iris data, that's basically what we're doing, right? And the data, the rows, the table should be what? The iris.data, which are these values. So we have sepal length, which is in centimeter. We have sepal width, which is in centimeter as well. We have the petal length, and then we have the petal width. If you take a look at the flowers, it's the same thing. Petal length and width, sepal length and width, same thing for the setosa, same thing for the virginica, right? So now we have the measurements. So based on these measurements, we can be able to cluster them. See, if you can do this based on your customers' spending behaviors, based on your customers' demographics and the rest, you can be able to cluster your customers. In this case, we are just having the details of these flowers, the size of the flowers, and then based on that, we are clustering them. The same thing applies. You can use the same code to cluster your customers as simple for any clustering problem, as simple as that. So what is our target? What is our target? What are we trying to predict? So df target is equals to what? Iris.target, because this is a target, right? For example, now if I go ahead and say iris.target, let's see what we're getting. You see, these are the targets. These are the targets that we are getting. As simple as that. So the targets is either what? Is either setosa, versicolor, or virginica. So these are the targets. As you can see, there are three: 0, setosa, right? And these are just the three targets. 0 is either 0 or 1 or 2. As simple as that. So my df target, I want to create a new column in my data frame, which is called target. So this should be equal to the targets, right? Iris.target. As simple as that. And then I'm gonna add the flower name because as you can see, there's no any flower name. We are just guessing. So df flower name, I want to create a column called flower name, right? And then I'm gonna be adding, it's going to be equal to inside the data frame df target. We're going to be applying some transformation. df target, right? Get the target, which is this 012. df target dot apply. We're going to be applying some transformation. Dot apply. What are we applying? We're applying a lambda function. I don't know, maybe if we are covering lambda in our Python class. If you don't understand lambda, please go ahead and browse what is lambda function in Python. Iris dot target name dot target underscore names and then X. As simple as that. So let me just go ahead and visualize my DF again. Okay, you forgot a comma. Wow, that's the beauty of Python. You even forget a comma and it tells you. So where do we forget the comma? Dot apply lambda X. All right. DF flower name is equals to what? DF target dot apply lambda X. Very good. Iris dot target names, and then we get the X value out of it. Yeah, I believe that should be it, right? I don't think there's any comma in that. I don't think there's any comma for that. I don't think there's any comma. Okay, let's just go ahead and make Python happy. Let's add the comma. It's invalid syntax. All right, why are we having these issues? Let's pay close attention and see. Lambda X iris dot target names. All right. Iris dot target. Okay, DF flower name. We created a new column called flower name. And then for the target, we want to what? Apply. Oh, sorry. Lambda is actually, there's a B in lambda. There's a B in lambda. Sorry. So DF. Wow, that's amazing. So if you take a look at the data frame now, we can see that we are having another column. We are having a new column that is what? That has the flower names. Beside it, you see we have Setosa, we have Virginica, and then the third one is what? We have Versicolor, which is not available here, but is available, but is somewhere around maybe the 100 or 150th row, right? So let me just print df.head. Let me print like maybe 40 rows. Maybe we can. Yeah, Setosa, okay. Yeah, okay, no problem, but it's day. It's actually day. It's actually day. It's actually day. So now we have added the target, and then we have also added the flower name. I told you in our pandas class that whenever you say DF and then inside your square bracket is the column name, you want to create a new column, this is how you do it. And then you apply this data into the column name. Same thing we're doing here. We created a DF flower name, and then we said DF target, which is either 0 or 1, right? Dot apply, we just applied a function, iris dot target names X. So for each and every 0 or 1, based on that, apply these names. For example, now if I go ahead and print iris dot target underscore names, you see we have these three classes. We have Setosa, we have Versicolor, and then we have what? We have Virginica. So that is what we are basically doing, as simple as that. We are adding these names to the data set. So the next thing that I'm going to do is I'm just going to define my X and Y, right? As usual, we are going to define our X and Y, right? Prepare the feature and target for prediction. So let me convert this to a markdown. Oh my goodness, there's no time. There's actually someone sitting beside me right now waiting for me. So let's prepare the feature. Prepare the feature, right? So let's prepare the features. So our X is going to be df.drop. Don't worry, if you don't understand some of the concept, I promise you guys I'm going to be explaining in depth in our next class, or you can just go ahead and watch the video again, but I promise you an explanation again. But this is actually very simple if you pay close attention, if you pay close attention to our classes. So df target, we are going to be dropping the target because we don't want the machine learning to see the target that we are predicting. And then we are going to be dropping the what? We're going to be removing the flower name. because we don't want you to see the flower name as well. And then we are going to be, yes, we want to say axis is equals to 1. As I told you in our previous class, axis is equals to 1 will drop the column, axis is equals to 0 will drop the rows. So for our X, let's say for the features, let's say in our house price prediction, this could be something like, does it have how many bedrooms it has? Does it have a balcony, this and that? So for our X, for our features, we want everything except the class of the flower and then the flower name. Everything except these two, right? This should be our X. And then for our Y, which is the target, should be what? DF target. DF target. Simple as that. The Y is what we are predicting, and then the X is what we are teaching the machine learning. As simple as that. So I'm just going to go ahead and press Shift Enter. So the next thing that I want to do is I want to scale my data. So I'm just going to create a variable called scalar, which is equals to what? Standard. I'll be calling this function that we imported earlier on, which is the standard scalar. Where is it? This standard scalar. And I told you that standard scalar scales your data within a close range, right? No data will be bigger than the other, as simple as that. That's why we are transforming our data. So X, let's scale our X, please. X scaled is equals to what? Scalar dot fit transform. We've done that in our previous class. Dot fit transform, then we pass the X. This X. We are just saying, hey, scale this for us, please. We don't want it to be so big. We don't want it to be so small, right? Because if it is so big or so small, it's going to cause confusion in the machine learning, right? If some numbers are so big, it will make the machine learning bias, right? It will be prioritizing some of the bigger numbers than the smaller numbers. That is why in machine learning, things should be in close range to avoid bias, right? So the next thing that I want to do is this, what we call an elbow method. I told you in our whiteboard, let me go back to the whiteboard. I told you in our whiteboard that the machine learning randomly picks the K value until it comes to an optimal value. For example, in this point, the optimal K value is 3. Why? Because we're having 3 clusters, right? But whenever you're teaching the model will be placing random K points until it finds the optimal value. So there's actually a method for picking the optimal value. For example, we know that we are dealing with 3 clusters. We can just write 3. But I want to teach you guys how to programmatically choose the optimal K value, right? I don't want us to like guess, we have 3. No, let's choose the optimal K value programmatically. So this is called elbow method. So just go ahead and browse. If you like ask ChatGPT, what is the elbow method? You're going to get more explanation. Use the what? Use the elbow method to determine the what? The optimal number of what? Clusters for K-means, right? Let's convert that to a markdown and let's run it. So the elbow method is actually simple, right? You just created a variable. You create a list to save all the optimal values, and then you look through, you say for K in, sorry, let me just create 10 optimal values. So K underscore range is equals to what? Range 1 to 11. I want to create 1 to 11 values. So between 1 to 11, we are going to train the model based on these 11 values and see which among the values is actually optimal for prediction. So how do we do that? It's actually simple. For K in range, for K in range, K range, which is just a number between 1 to 11. If we like, we can just say 3 now, since we know 3 is the optimal value. But let's do it programmatically. Let's learn some new concept, please. So for K in range, K range, which is a number between 1 to 11, right? Km is equals to K means is equals to what? Let's call the K means classifier, and then pass it the what? Pass it the number of clusters should be what? The number of clusters should be K. This one for K, right? And then what? And then the random state, as usual, is 42. By now, I know you know what a random state is. Random state is 42, right? So km.fit, I told you that whenever you say fit, x scaled, you're fitting the scaled value of x into the what? Into the k-means. So based on that, right, you want to append the value, this list, you want to append the optimal value into what? Into this list, dot append, just like we did in our beginner Python class. Whenever you want to add something to a list, you say, you call the list name and you say dot append. What do you append? This is what we call km.inertia. Inertia is distance, right? The distance, the optimal distance, km.inertia is actually, I'm not creating this, actually built into scikit-learn. So km.inertia underscore, that is how it is, right? Sum of the squared distance to the closest neighbors, that's km.inertia. So it will choose what is the distance that is closest to the neighbors. So it will choose the closest one, right? So let's plot that and see. Let me just, okay, x scaled. We're having arrow. Okay, x scaled is actually double L. X scaled, another arrow. Okay, let me see why are we having this x scaled. Let me just copy that and paste it so that we don't have any error. Wow, maybe I did not run this, right? Okay, scalar, I think scalar, I think maybe scalar is 1L, right? Yeah, it's 1L. Beautiful. You know, these libraries are so big, right? They are so big. They are so big. Inertia, there's no E. You're going to be making spelling mistakes. But the main thing, they are actually simple. The main thing to understand is how this algorithm is working under the hood. That is actually the main thing. You don't have to memorize these things. So let me just visualize this for you so that you understand why do we even call it the elbow method. So plt.figure, let me create a figure. plt.figure. By now, I know you guys know how to create a plot. So the fig size, which is the canvas size, is going to be the image size of the plotting. Is always what? Let's now, we've been adding 16, but today I'm going to add just 8/5. And then plt.plot. What am I plotting? I want to plot this k range, right? plt.plot on the x-axis, I want to plot the k range, and on the y-axis, I want to plot the optimal distance. The optimal distance, which is SSE, right? You can just name this any variable. It's just by convention that we name it SSE, right? So, and then the marker, let me just choose, let me add a marker. The marker should be something like small o. If you like, you can use X, but for me, I'm just going to use small o for the marker. So I'm going to add title. plt.title is going to be what? It's going to be number of what? Number of clusters. Sorry, elbow method. I forgot. Elbow method for what? For optimal k. And then plt.x label is going to be what? The number of clusters. Optimal number of clusters, which is k. Don't worry. If you see this, you'll understand. If you see it, you'll understand. Let me just visualize it for you guys. So plt.y label. The y label should be what? Should be the sum of the squared distance. Sum of the what? Squared distance. Which is what? Which is SSE. That's why we named the variable SSE. But you can name it anything, right? So the next thing is let me just add a grid, plt.grid, which is true. I want to add lines to my chart. That's as simple. That's just plt.grid, and then plt.what? plt.show. Wow, first try. So the reason why we call this the elbow method, if you take a look at this chart, it looks like an elbow, right? It looks like an elbow. You can reuse this code. This code is used to find the optimal value for K in range 1 to the number of samples that you want. K means create a cluster of K, and then the random state is 42, and then fit the data into that. So let's see. It says the elbow method, we always choose the number. Let me plug my laptop before it dies. We always choose the number that is closer to the elbow. And if you take a look at this data, we can see that 3, you see, the elbow point from 2 is 4, right? So we see that 3. That's why I told you that by mere looking, we know that it's 3. But let's do it programmatically. Let's do it programmatically. Now, the reason why we know that it's 3 is because our data is very small. We know that we are only having 3 types of flowers, right? So we know that we are having 3 neighbors. What if we have like 1 million neighbors, right? We don't want to be guessing, honestly. So this is the optimal way of finding the optimal number of points. So this is basically finding these points, 1, 2, and 3. The center of the neighbors. That's basically what we just found using this elbow method. Please go ahead and browse more about it. It's actually very nice, very amazing algorithm, right? So the next thing I want to do is I want to apply the k-means clustering. Since I already know that the optimal k-means is 3, let me just apply that to my data. So I'll just create a variable called k-means, and then I'll call the k-means that we imported. Where is it? K-means. Yeah, you see, we call the k-means cluster. That is the name of the algorithm. So it's equals to k-means, right? And then the number of clusters is 3. We have already calculated that. Number of clusters is what? Is 3. And then the random state is always 42 for me. The random state is 42. Beautiful. So the next thing that I want to do is I want to add the clusters to my data set. I want to add the clusters. I want to add the clusters column. So df cluster is equals to what? Is equals to this k-means dot fit predict dot fit the predictions x scaled, right? So let me go ahead and run that. Okay, k-means. Okay, we are having an error. K-means object has no attribute fit predict. Okay, this is where we're making predictions, please. Fit predict. Then we pass the x scaled. This is how you make predictions using what? Using the k-means cluster. K-means dot fit predict. As simple as that. So let's open our DF. You see, we can see it has already clustered everything. Cluster 1, this Setosa belongs to what? Cluster 1, cluster 2, cluster 2, cluster 2, cluster 1, right? The Virginica, cluster 0. The Virginica belongs to cluster 0. You see, we have added the clusters, but let's make the prediction. Let's see the PCA. Let me visualize the clusters for you so that you understand what is happening, right? There's what we call dimensionality reduction. We will choose the optimal clusters and then visualize it and then place it on the data point so that you understand. Don't worry, I'll just code it and then show you guys PCA. Don't worry, this is a bit advanced data analysis, so practice makes permanent. Once you practice it, you'll understand, right? I know it's a bit advanced for you guys, but once you practice, you're definitely going to understand these things. They are not magic, actually. So PCA is equals to the PCA we just imported, and then the number of components is 2. 2 number of components, right? So the principal component analysis for the X is what? PCA, which is just the variable we created, dot fit transform. I'm going to be explaining this for you, don't worry. X scaled, the X scaled. Don't forget, we are always passing the scaled X, not the X, the scaled X. So let's add that to our data frame. DF PCA1, the principal component 1 is what? The XPCA. Everything for the row and then the first column. DF PCA2 is equals to what? The XPCA, everything for the row but the second column. If you've missed my Python beginner class, this is definitely going to confuse you. But if you haven't missed that one, this is going to be so easy for you guys. So let me print DF for you now. So you see, the PCA1 and the PCA2 has already been added into the data frame as well. So I want to explain this, but let me just visualize and then explain for you guys as quickly as possible. We're almost 1 hour, 38 minutes. Oh my goodness. So the next thing that I want to do is I want to visualize my PCA. As simple as that, we're almost done. We'll just visualize this PCA and we'll make predictions and then we are done. So let me just plt.what? Plt.figure. Is going to be what? The fixed size is going to be 8 by 6. Let me make it a little big. 8 by 6. And then SNS.what? Let me create a scatter plot. The data that I want to pass to the scatter plot is DF, the data frame itself. On the x-axis, I want the PCA1. And on the y-axis, I want the PCA2. Don't worry, I'm going to be explaining why we need the PCA. And then my hue is going to be the clusters. I want to see the clusters. And then the palette is just the color palette. The palette, is it 1A or 2? Yeah, I forgot. Let me just choose 1A. Sorry, 1E. And if it fails, I'll choose 2E. It's what? Viridis. It's a funny name. And then my S is going to be 100. So my centroids which is just the center of the clusters. I told you that the center of the clusters is called a centroid. It's equals to PCA.transform, right? Then K means dot cluster center underscore centers. You don't have to understand this. The main goal for you to understand is this. Where is it? This here. K means dot fit predict. But if you want to go deep into the rabbit hole, you can do principal component analysis as well. So now I'm almost done. So I want to add the transformation. Sorry, I want to add the centroid. The 2D centroid is going to be my battery. 1 second, please. Let me just connect my system. It's like I didn't on the power when I connected it. Yeah, we're good to go now. So where are we now? What are we doing? So we are creating the centroids, right? K means cluster. We want to add the centroids into this center of the cluster. Nice one. So let me plot that as well. Plt.what.scatter. Let me create a scatter plot. And then I'm going to be passing the centroids. These centroids that I just created, the 2-dimensional centroids. Don't worry, once I visualize these things, you're going to understand them. Nice one. Let me just visualize this. The reason why I'm doing complex programming is just for you to understand, right? We can just go with this. If we like, we can just choose the optimal K value and then move on with our lives. But I want you guys to see what is actually happening inside these algorithms. That is why I'm creating these complex functions to visualize what is happening for you, right? If we like, we can just say, yeah, we have already done the visualization in our whiteboard. This is the centroid. These middle points are the centroid. So, but how do you believe that they're actually the centers in your data points? That is what the algorithm is actually doing under the hood. So that is why we are doing these things to visualize the clusters for you so that you see them, right? So I just want to plot the first centroids, right? Which is everything for the row and then the first column. And then for the second centroids is I want to plot everything for the row and then the second column. As simple as that. Centroids, which is just the center of our data frame, centroids 2-dimension, is what? Everything for the row and then the first column. S is going to be 200. 200 is, S is basically the size of the cycle. So maybe this 200 is going to be so big, but we'll see it after visualization. And then the C is equals to red. Let's make it red. And then the marker should be X or yeah, let it be X. The marker should be what? Should be X. Let me just make it big so that you see it. And then the label should be what? Should be centroids. Yeah, nice one. So don't worry, we are done. We are done. So let me just add a legend, plt.legend. And then let me add a title, plt.title. The title is going to be something like, let me see, K-means clusters visualized in 2-dimension. Not everybody is going to visualize this thing for you, honestly speaking. You can find many data analysts and they cannot be able to visualize these things for you. So that's why I'm doing this thing for you. Maybe you can go around and find on the internet. Nobody is going to visualize centroids for you, honestly speaking. K-means clusters visualized in 2D with centroids. They're just going to teach you how to maybe perform clustering, and then they'll move on with their life. But we are doing things in an advanced way here. So plt.xlabel, our X label should be what? Should be the PCA1, should be the PCA1, which is the principal component analysis. If I were you, if I find things difficult, I will be jotting them down. Then you can go ahead and perform your research. What is principal component analysis? Why are they useful? When do we use them? Why do we use them? I'll be jotting things down if I were you, right? So plt.ylabel, let's add the Y label. Whenever you hear me saying something new, you just write it down and then you browse it, as simple as that. And then you get more points, you get to know it more. Plt.what? Let me add a grid, which is going to be what? Which is going to be true, and then plt.show. Wow. So the moment of truth, let me just run that and see. Wow, is predicted. So we are having some errors where SNS does pay plot. Okay, X is PCA1, Y is PCA2, hue is clusters, the palette. Okay, where is the problem? Where is the problem? Most of the time Python indicates the problem, but this time it's not indicating. Okay, why? Okay, no problem. I can do it manually. Let me just see where I made the mistake. SNS.scatterplot, no problem. SNS.scatterplot. Scatterplot is correct, okay. The data I'm passing is the data frame itself, which is DF, okay, which is correct. And then on the x-axis, I want the what? The PCA1, which is just this value. And then on the y-axis, I want the PCA2, which is what? Which is this value, which is correct, comma. And then for the hue, I want the clusters. which is this. Okay, sorry, mine is cluster, not clusters. Cluster, right? Mine is cluster. I mistakenly added S. You see, because of this S, everything refused to work. Wow, we are getting there, we are getting there, we are getting there, we are getting there. You see, we have 3 neighbors. We have the green class, we have the yellow class, and we have the green class. We have 3 clusters. So we are getting there. The only problem now is I want to plot the center of the neighbors. So line 3, centroids the PCA transform K means the cluster center. That's why we're having the, okay, K means object has no attribute, cluster centers. Okay. Okay, sorry, there's an underscore. Cluster center has an underscore. I remember, where is it? K means the cluster centers. It's actually a built-in function and it has an underscore. So we're having another error. Let's check it. Let's check it. What is the error? X and Y must be the same size. Okay. Are they not of the same size? Are they not of the same size? Are they not of the same size? PLT, 2-dimension, the PCA transform, okay? Okay. Okay, everything for the row, all right? And then everything for the column. Just give me a minute, I'm gonna pinpoint my problem. Centroids 2D0, all right? PLT.scatter. On the first scatter plot, that's why we're having the problem. So PLT.scatter, which is line 4. Okay. Centroids 2D. Everything for, oh, sorry, it's my mistake. If you take a look at it, there's no comma in between them, comma. Wow, that's amazing. Nice one. So we are able to solve our problem. So please pay attention here. Let me just zoom in a little bit for you guys. It took a very, very complex algorithm to visualize this. So let's make sense out of it. Let's make sense out of it. So why do we do this? Why did we even do this? The reason why I did this is because I want you guys to see that this algorithm is basically placing these points in the center. For example, you see we have the green neighbors. We have what? We have the yellow cluster. We have what? We have the purple cluster, right? So the purple is cluster 0, as you can see in the legend, and then the green is cluster 1, and then the yellow is cluster 2. And then I told you that what the algorithm does under the hood is it places centroids in the center of the clusters so that whenever a new data is available, they will use that to make predictions. They will use that to cluster the new data. So you see, now we are placing, our centers are literally correct. We have X in the middle of purple, we have X in the middle of yellow, and then we have X in the middle of what? We have X in the middle of, what do we call it? In the middle of green, right? So you don't have to understand this. Honestly, this is very, very advanced. What I want you guys to understand is just this. Forget about this PCA. If you like, you can browse more about it. What I want you guys to understand is how to find the optimal K value, right? Using the elbow method. This is very key. This is very key for you guys. And then how to fit transform, how to make predictions using the what? Using the, what do you call it? Using the clustering algorithm. But the reason why I did this PCA is I did some principal component analysis, right? So what is happening here, you know that, let me just see if I can be able to explain it for you guys a little bit. So what is happening here? We just said PLT.figure. This PLT.figure is just creating this white canvas, this whiteboard of the size 8x6. So if I like, I can say 10 by 8. And you see the size will change. You see, now it's much bigger, right? 10 by 8 is even much bigger. As simple as that. So what are we doing in the next line? So SNS.scatterplot, you know that this scatterplot is this. We have already done that in our data visualization class, right? So we are using Seaborn scatterplot for this thing. And the parameters are data is DF. The data, it expects a data. So we are passing the data frame to it, which is our DF, right? And it's expecting the x-axis. This is the x-axis. This below, this is the x-axis. And then this is the y-axis on the left-hand side, right? So you have to pass data to it. So on the y-axis, on the x-axis, I said I want PCA1. What is PCA1? This is our PCA1. We just imported our principal component analysis, and then we just transform our data where we extracted the two most important features in our data set. That is why it is called a principal. You have a principal, right? If you pass your data into a principal component analysis, it will extract the two most important features inside your data, right? So that's why we name it PCA1, and then we said the first column of our PCA, and then PCA2, the second most important data. That is what we are doing, right? And then we added that to our data set. So, and then we are plotting the two most important data, two most important things, because if you don't use your PCA to plot this, these data will be scattered everywhere. That's why you use the two most important features to plot this data. That's what we are basically doing. And then the hue, we have hue here, right? We have hue. So what does this hue mean? Hue means color each point based on its k-means. Color it based on its cluster. Is it either purple, cluster yellow, or cluster green? That's basically the hue. Use the cluster to color the points. And you all know that we have three clusters, three types of flower. The palette is very simple. The palette is a pleasant color. Just use a pleasant color. And then this size, S, is the size of these dots. For example, let me say the size is 200. You see, now the size of the cluster has increased. But I want you guys to see it clearly. That's why I said, let me just change the size to 50. You see, now the dots are little, but 100 is a bit pleasant to the eye. That's why we choose 100, right? 100 makes things nice, as simple as that. Very good. So let's move to the next point of the class. What did I say? I said the most complex one is the centroid study, which took a lot of time, honestly speaking, and thinking. So what are we doing? Let's explain this. We are giving a word. Centroid study means we are saying that PCA.cluster centers. Sorry, let's start with the .fit transform. PCA.transform, what are we doing here? We are just converting them into 2D space, two-dimensional space like features. We're just converting them into, I don't know how to explain two-dimensional space, honestly speaking. Two-dimensional space, just go and browse that. I don't know how to put it in a layman's understanding. It's just something that has 2 dimensions. And we have 2 dimensions, we have 3 dimensions, right? So we are just converting them into 2 dimensions, right? So, and then because of what? Because these, what do we call it? K-means cluster center actually returns what? It returns a 4 dimension. And we actually want our data in 2 dimensions. That's why we are saying PCA.transform. We are transforming them into 2 dimensions, as simple as that. So you all know that I don't have to explain this. The S is the size, the C is the red, right? The C means the red color for visibility. We are choosing red. And then the marker is X, as you can see. We have X in the middle. If I like, I can even make this marker to be M, to be my name, something like that. Yeah, sorry. Okay, markers are, they have already changed that. They have already changed that. Marker is either X or 0. Before you can even add Y or something like that, but now it's either O, small, I believe it's small O. Yeah, it's either small O. You can see it's either small O or X. They have already updated the library so that we cannot abuse them. So it's either O or X, right? I think there's even hyphen for marker, right? I think there's hyphen, right? I don't think there's hyphen. Let's see if they have provided us with some options. Okay, marker style. Okay, or recognize marker style. You can browse the marker style, but I believe before you can even add Y or something like that. But now it's either X or small o, something like that. So the label, this label is this, right? You can see the label means the legend. centroids. That's basically it. That's basically it. And then we added title, which is this, right? K-means cluster. And then on the x-axis, we say PCA1, which is here. On the y-axis, we say PCA2, which is here. And then grid is equals to true. As you can see, we have lines on the chart. And then plt.show, we are just saying, show me my visualization. As simple as that. Nobody can explain this concept line by line for you like this, honestly speaking. So in summary, we just use our principal component analysis to reduce our 4-dimensional flower data into 2-dimensional so that we can visualize all the hidden patterns in them, right? And then we plotted the clusters found by the K-means. The K-means was able to find 3 clusters, right? As simple as that. And then their centers, which is marked by this red, the center of the neighborhood for each neighborhood, right? As well as what? The groups of similar flowers. Some of the neighbors, as you can see, it has already found that for each and every group. So I don't know, so should we make the prediction for our next class, or should we just, should we make the predictions? I don't want to give you guys an information overload. Should we check the accuracy of the data, or should I just allow you guys, or should we do it in our next class? Honestly, because it's almost 10 p.m. now. Should we do it? Should we make predictions, or should I allow you guys to do the prediction? Because I've already done the heavy lifting for you guys. The only thing for you is just to split your data. Split data into what? Training and what? Testing. And then you just check your accuracy, as simple as that. Because it's done already. We have found the optimal K value. We have visualized it. So there's nothing left again to do. It's just to make predictions. So x_train, if like I can do it for you, if like I can just allow you guys to do x_train, x_test, comma, y_train. This is actually the most easiest part, comma, y_test is equals to what? Train test split. Train_test split. You pass your x, you pass your y, and then the test size. How many percent do we use for testing and training? As usual, 20% for testing, right? Which is 0.2. And then the random state, let's choose one for now. Random state. Let me just choose one so that you guys should know that we can choose any random state that we want. It's just for reproducibility purposes. So let me just train the model. Train the model, right? So we just K nearest neighbor. Always name the model, the name of the algorithm, right? So KNN is what? Call the model. Let me just go over and copy it. Where is it? Here is the model. Let me copy it. And then I come down and then I paste it. KNN is equals to what? My K nearest neighbors model. And then the number of neighbors, I'm just gonna put 10 so that it will train well. Neighbors is what? 10. It accepts some parameters. If you want to know more about this, just go to the what do you call it? I don't know why my internet. Go to the scikit-learn website and then look for what is it called? The parameters. Right? Just go to the scikit-learn website and then understand the parameters that we are passing. Right? Let's just continue with our life. So the number of neighbors is, I'm just going to be choosing 10. So let me feed my data. KNN fit. Whenever you say fit, you're training, right? So I'm going to pass my X train, and then I'm going to pass my Y_train. As simple as that, right? Shift enter, it will start training. There's an arrow, random state. Okay, there's an arrow here, random_state. Yeah, random_state. So the model is almost done training, right? We have already trained our model. So now let's just check the accuracy and move with our life. So the accuracy is going to be ACCU. Accuracy is going to be k nearest neighbor dot score. Let's score the model and see. Let's pass it some X test data, which is X test and Y test. X test is the feature that we are passing, and then Y test are the predictions. So it's just going to see the testing data against the Y, right? The target. As simple as that. So let me just print the accuracy. Print something like in a formatted string, predicted class, sorry, accuracy or model accuracy, something like that. Model accuracy is equals to what? The accuracy. And then I'll just convert that to a two significant figure, the 2F. The last time it did not work, I pray it works now. Wow, 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 that's beautiful. We have 97% accuracy. As you can see, this model is very accurate. I thought as much. Why? Because if you take a look at the centroids that it placed, it's almost perfect. It's almost perfect. It's almost at the center. Even for this yellow, it's almost at the center. So 97% is expected, right? That's the accuracy of our model. So let's make predictions, please. Let's make predictions. So let me have a sample of a flower. So sample is going to be, I told you that whenever you're making a prediction, convert it to a two-dimensional array, use two square brackets. So let me choose the size of a flower. Just choose a random size. The petal length is going to be 4.8 centimeter. The width is going to be 3.0. And then the sepal length is going to be 1.5 because it's the smallest. And then, okay, let me see the flowers first. Okay, let me see the flowers. All right, let me just try and mimic versicolors. So the sepal length, I'm just going to pass 1.5, and then it's small now. I'm just going to pass 0.3 centimeter. So let me just make prediction. Prediction class is equals to what? K nearest neighbor dot what? Dot predict. And then I'm just going to pass my sample, which is this. I'm just calling the name of the model, which is KNN dot predict. Then I'll pass the new sample. Sorry, sample data. And then just get the first class classification out of that. I want the first classification. So predicted name is equals to what? Iris dot target, because this is going to produce a number. So we want to use that number to see which target name is it, right? The target names and then predicted class. See, let me visualize things for you here, honestly, so that you guys should understand, right? So now if I print this pred class, pred underscore class, you see we're having 0, right? We're having 0, no problem. It predicted as 0 bar. So let's say we have, I told you that the iris.target names underscore names is going to print either setosa, versicolor, or virginica. And I told you that this is actually a list. How do you get the items in a list? By their index. The index of setosa is 0, the index of versicolor is 1, and the index of what? Virginia is 2. So if I say target name 1, so the target name 0, I get what? I get setosa. Target name 1, that's the importance of our Python basics. That's why we did our Python class. I get versicolor, and target name 2, I get Virginia. So, and our machine learning predicted that the predicted, the pred class is 0. Let me delete this target name first. You see, it says is 0, right? So let's pass that target class to the iris target class and see which class is it. So iris dot what? Dot target names, and then pass the index, which is the predicted class, which is the value returned from the predicted class, either 0, 1, or 2. right? So, and then I'm just going to go ahead and print that. Print in a formatted string. What am I going to print? Predicted class. Then what am I going to pass? I'm just going to pass my my pred name, which is this. So this should be pred name. I forgot my predicted name, pred underscore name. Wow, you see, it is Setosa, right? Setosa. So this is just a warning. This is just a warning. The reason why we're having this warning, they just want us to convert this to a pandas data frame and pass the name of the columns, but we don't have to do that now. So we have already predicted this sepal width, sepal length, petal width, petal length as what? As Setosa. So let me see if the internet is going to allow me to get the tables. Iris dataset table. Let's see if the internet is very freaking annoying today. So had it been the internet is working, I'm just going to get an accurate petal length so that we can be able to see, we can be able to make a prediction. But the reason why I believe this model, honestly speaking, is because I got a 97% accuracy. So whatever I pass, whatever this model is speeding out, I have 97% trust with it. As simple as that. So let me just go ahead and print a confusion matrix for you guys to see how many times our model has messed up. Y underscore prediction is equals to what? K nearest number to predict. Let's predict our X test. And then my confusion matrix is going to be, I'm just going to call the confusion matrix function. And then I'm just going to pass my what? Y underscore test. And then this predicted value. Test it against this value that my model predicted. As simple as that. What am I doing? I said Y prediction is, I want you to predict using the X test, the 20% of the data. After that, here is the Y test, and here is the Y prediction. Compare it against the Y prediction. It's like a marking scheme. Here is the answer. Compare it against the predicted value and score my model. This is what we're basically doing. So let me plot that. plt.figure. Today we are plotting everything. plt.figure. I'm just going to say the fixed size is going to be what? Let me put 7 by 5. 7 by 5. If you're good in visualization, you can be able to visualize literally anything, right? So I'm just going to say sns.what? Heat map, confusion matrix, pass my confusion matrix. My annotation is going to be true, right? And then my FMT is going to be D as usual. It's going to be D. And then my color map is going to be blue. It's going to be what? Blue. Blue. Beautiful. And then my X label, plt.x label, is going to be what? It's going to be the predicted value is always below the predicted value, right? Predicted value. And then my y-axis is going to be the actual value. plt.y label is going to be what? It's going to be the actual value. Oh my goodness, that's a mistake. The actual, oh, what am I doing? The actual value, right? And then I'm just going to say, I'm just going to add a title. plt.title is going to be a confusion matrix. My hands are tired, honestly. And then plt.show, right? So let's see our confusion matrix. There's an arrow, AX. Where did I put AX? Did I put AX? Unexpected argument CMAP. Oh, I typed CMAP twice. Double M. It should be 1M. Okay. Color map. Blue is unknown. Okay. C map is equals to blues, not blue, blues, the blues, the blues. Which one is the blues? It's Chelsea, right? So the blues, beautiful. So we have already plotted the confusion matrix. Wow, I'm seeing our model has performed pretty well. I told you that confusion matrix is very simple to interpret. Don't allow anybody to confuse you. Confusion matrix does not confuse us. See, this diagonal are the actual values. Whatever you see here, sorry, no, not like this. No, this is not the thing that I'm looking for. I think it's sheep, right? Yeah, this diagonal value are the actual values, right? And then whatever that is here is where the model made mistake, right? So 11 times our model, the actual value is 0, the class is 0, and our model was able to predict that is 0, right? As simple as that. 12 times the class is 1, the actual value is 1, the class is 1, and then our model was able to predict that it is 1. There's no any mistake. And then 6 times the class is 6, and our model was able to predict, sorry, the class is 2, and our model was able to predict that the class is 2. Only one time that our model made mistake. I told you that these diagonal values are the correct values. If you see a value here or here, these are the times that your model made a mistake, right? As you can see, 0, 0, 0 mistake, 0 mistake, 0 mistake, 0. This is how you read a confusion matrix. Draw a line diagonally like this. The values that you see in these diagonal boxes are the correct predictions. Anything apart from that is a mistake. That's as easy as that. So our model made mistake only once. Only one error. Only one error, right? So let's print a classification report. I told you that it's just like a report. And then we are done with for today. Classification report. Oh my goodness, I'm sorry guys. People are actually sitting right beside me waiting for me. I'm sorry guys, please. So print classification report is going to be what? Classification report, right? Let me beautify that a bit. Yeah. Beautiful. So let me just go ahead and add the report below it. So print, call the classification report function. Where is it? Which we imported. We have imported that already now. It's not like something that we have not imported. Have I imported it? Yeah, here it is. Classification report. So these are just, I told you that it's actually the coding part is a bit easy. So I'm just gonna call my classification report and I will just pass my y test, comma, y prediction, comma, and then the target names to see if it has successfully predicted the target names. Target name is equals to what? Iris.target underscore names. Simple as that. Yeah, we're having an error. Target names, not target name. Target names. Another error. Target names. Oh, sorry. Yeah, beautiful. So here is our classification report. Here is our classification report. You see, we have for Setosa, we have 100% precision, 100% recall, 100% F1 score, right? We're able to, out of 11 predictions. For the Versicolo, 100, 92% recall, the precision is 100%, the F1 score is 96%, and out of what? Out of 13 predictions. And for the Virginica, 86%. I believe this is where we made a single mistake. That's why the precision is 86%. And the recall value is what? The recall value is 100%, and the F1 score is 0.92% out of what? Out of 6, right? And you can see the accuracy of the model out of 30 predictions. The reason why the prediction is 30 is because we are using the 20% of our data. So 11 plus 13 plus 6, that's 30. So out of the entire 30 predictions, we were able to have a 97% accuracy. So this is how you read a classification report. If you want to know more, go and read. It's actually go and research about precision, recall, and F1 score, right? It's actually very simple now. How precise is your model? The recall value, how many times your model got it right? And how many times your model was able to classify wrong as right as false positive, and false negatives. So just go ahead and research this. I don't have enough time to explain this. They're actually very simple. As for me, it's plain English, precision, recall. Maybe the F1 score is something. If not, recall and precision are plain English as well. And the accuracy, you don't have to even browse the meaning of precision and accuracy and recall. Maybe go and browse the F1 score. Support is just the number of samples, as simple as that. So this brings us to the end of today's class. I believe the reason why this is a bit advanced is actually almost the end of our advanced data analysis. So that is the reason it has to be advanced now. It has to be very advanced. It has to be very advanced. Let me see if my mic is still working. Yeah, it has to be very advanced. My mic is working. So this brings us to the end of today's class, please. Please, I do encourage you guys to go ahead and write everything down, please. Right? If you like, I'm going to be sharing this this beautiful, what do you call it? This beautiful Jupyter notebook with you guys. If you like, I'm just going to share it with you guys for free. Right? Just go ahead and ask if you like, and I'm just going to drop it for you guys. So please just practice makes permanent. Let me just go ahead and add a title to this. KNN, what do we put? Something like KNN, right? Classification, right? Using what? What do I put? KNN classification notebook, something like that, right? Is that okay? Something like that. No, we are having some errors. Yeah, KNN classification notebook, right? K nearest neighbor. Let me just add that in a bracket or something like that, or in a square bracket. K nearest neighbors. K nearest neighbors classification notebook. So if you like, I'm just going to go ahead and let me just go ahead and share this with you guys. File, download. KNN classification notebook. Nice one. So please, this brings us to the end of machine learning. And officially, we are done with our machine learning class. In our next class, we are going to be, I don't know. I don't have the outline in this computer. I have it on my other laptop. So I believe next time we are going to be, I don't know what we're going to be covering, honestly. I don't know, is it possible to share files via Zoom? Don't worry, I'm just going to drop it. I don't know if it's possible to share notebooks. Is it possible? Because I've never tried that. Is it possible to yeah, it's possible. Let me see if I can drop it, please. Let me see if I can drop it. Ishola, let me just go ahead and drop it. Let me just drop it for you guys. But please, it took me almost how many hours now? It took like 3 hours of my life to compile this notebook right now, as you can see. So please don't make it worth it, right? Make it worth it, right? Let it be worth it, please. Don't just throw away this notebook. Use it, please. Honestly speaking, you can just search anyway. There's no tutorial on the, I've searched through the internet. There's no tutorial that's going to break down how these algorithms are working. There's no tutorial like this. There's no tutorial that will show you the internals of this algorithm. If you don't believe me, you can go and search how the internals of this algorithm, how they are working, how they are placing these centroids in your data points. I've not seen any tutorial that visualizes how these algorithms are working under the hood, honestly speaking. I haven't checked the scikit-learn library. They just provided a little documentation for that. So please make use of it. So it's not even heavy. It's only 191. It's only 191 kilobytes. Yeah, thank you, Agbola. You're welcome. Just make me proud. Please make use of this. See, if you don't understand, you have language models. You have many things. You can just go ahead and line by line be explaining this. Be digesting, right? Be digesting, right? The only thing that is of value here is the concept. Since you know such concept exists, you're okay. You can just go ahead and search through them. What is PCA, right? Why do we use PCA? Principal component analysis. You can even download another data set and perform classifications. Sorry, clustering, yeah. Classification and clustering. You can use this as a blueprint to do your own analysis, right? As simple as that. Because if you take a look at the PCA, we did not even pass some individual rows to it. We just said PCA and use our scales data to find two most significant features out of it. You see, we did not even pass a column name or something like that. It did it automatically. So you can use this as a blueprint for your clustering analysis, right? You just have to change the data set and find the optimal K value, which is done automatically as well. You don't even need to change anything there, right? What you have to do is just to change your targets and then perform the transformation on them, and then the rest of the code will do the rest for you, even the confusion metrics and the rest. So please make use of this notebook. Nice one. So with this, we come to the end of today's session. So please, we have formally finished our machine learning course. Next, I think we are jumping into, I don't know, it's something like creating dashboards using Excel, which is actually very easy. So we've done the difficult parts. So please, I expect you guys to go ahead and, yeah, Ishola, no problem. I expect you guys to please go ahead and read. Go back through the videos, read. If you want us to give you like maybe a week or something like that to finish reading before we move into our project, no problem. You can give you maybe 5 days, 1 week to go and prepare yourself well. Then we dive into these projects, right? So with this, I'm just gonna call it a day. So if Justice is here, I'm just gonna pass the class to you. And if Justice is not here, we can just end the session and then have a great night. Yeah.
Yeah. I hope that it's also excellent on the side of the students. You know, I want them to know that it's not just this class. Most of these machine learning classes, there's very limited information out there in terms of people who have got ground knowledge in it. So I hope you people value what you guys are getting. And if you can't value it less, the only way you can show that you value it more is when you spend more time on it. You are not developing yourself for your trainer, Mohammed. Neither are you doing it for IGTA. You are doing this for you. So I want to encourage you all that the more you continue to give up time, someday in future, all of this will pay in huge coins. If actually that is your desire. But I always say that money shouldn't be the motive for anything you're doing. Let your motive be just a desire for more knowledge. Just seek for more knowledge. The beauty is the more knowledge you acquire, money will definitely find its way
Honestly,
through the steps. Yeah.
more knowledge, more money.
Yeah. So I want to encourage you all to keep it up, and hopefully I think we'll give them 1 week MK so that they can keep up before the so that everybody can be part of the capstone project. Yeah, so
Yes.
that everybody should be carried along. So it's okay. Good night to you all.
No problem. Thank you very much. So see you guys. So Justice, please, if there's any issue, don't please do not hesitate to share it with me. And we're officially giving you guys a break. Just take this week. Go to day one. If you like, go back to Excel day one. Right? Go back to Excel because we are diving back into Excel again. So you see, use this 1 week. Go and refresh your Excel skills. Go and refresh your programming skills. Start data visualization from scratch, right? Then perform your linear regression, your logistic regression, and all your classification, clustering, and everything, right? Then we dive back into Excel, we create our dashboard, and we start discussing about our capstone project, right? Yeah. I'm seeing people are, I don't know, people ask, yeah, thank you very much. My laptop developed a major issue. That is why I'm unable to submit my assignment. Okay, no problem. See, fix your laptop, please. Fix your laptop. Find a way to fix it, please. Don't use that as an excuse. Find a way to fix it. Find a way to fix it, please. Yeah. Yeah, Joseph, if you're having challenge, please just drop it to the host, and then they are going to forward it to me. Or maybe we're just going to open maybe a Telegram group, something like that for the chat, for explicitly for solving these solving problems, right? As simple as that. So see you guys in the next sessions. Good night. So Justice, I'm going to be passing the class to you because I've seen that Maudine is raising up his hands because we're actually going to see a sick colleague right now. So I'll be handing over the session to you, please.
Yeah, it's okay. I think it's we just have to say good night. Unless Modin, is there something you can
just
unmute?
just listen to Modin. If it's a technical issue, I'll attend to it maybe later before I sleep or tomorrow or something like that.
It's okay.
Yeah, thank you.
Yeah. So Modin, what's your concern?
Thank you very much. I appreciate you all for all what you have been doing for us. Because of time, let me make it very quick. I just want to beg on behalf of all the students, we are having a challenge of these materials. Although when we started, we have all of them in Telegram. Later, all of them are wiped out. We cannot access them again. We have a lot of them, but some of them we miss them. So also now, as our tutor said, this type of training is not something somebody should lose if we know the importance of it. But I think that material is supposed to be able to be available till the time that we do our our project, but unexpectedly it just disappear. So that is why some of us are having challenge of that material. Please, if you can help us, I don't know what actually happened then, why it was removed, but if there is something you can do, sir. Thank you.
Good night to you all. It's acknowledged. You guys will have access to the materials from the YouTube page for 1 week from now to next week. So all of them will be made available for a period of 1 week. So people should make sure if you need to go through any of them, take within now and next week to go through all of that. Wishing you guys the best. Good night.
Good night, sir. Thank you.